Hi guys. I on purpose put on that song so that I hope it will make you more excited. I hope so. Okay, when that song came out, do you remember what year is it? Are you still in your primary school or already in secondary school? Do you remember the memories that came with that song? Okay, I should stop now. Okay, today we're going to learn about the integration. So this is the first installment of the chapter 4. So basically this is all that you're going to learn in this chapter. So for today's lecture, I'm going to cover this one and area under a curve. Okay? So a function f is an antiderivative of f if f prime x. Okay, I will make it simpler for you to understand. Okay, this can also be represented like this. So the antiderivative is always termed as f capital letter x. Okay, antiderivative f x. Okay, so the derivative of antiderivative, okay, is fx. Okay, so to find f capital letter x, what we should do? We have to integrate f small letter fx. That's all. Okay, so the antiderivative f is always termed as f capital letter x. So the derivative of f capital letter x is fx. Fx, the normal function, okay? So to find the antiderivative fx, we have to integrate f small letter x. Okay, I think this will make much more sense when we do the example. Okay, so now the example 1 wants us to find the antiderivative for each of the following function. Okay, we'll start with example 1a. So a is 4x equal to fx equal to 4x. Okay, so to find f capital letter x, which is the antiderivative, okay, we have to integrate fx here, which is 4x. Okay, remember integration 4x dx. Okay, remember integration, guys. Integrate, you have to, this one is to the power of 1 plus 1 got 2 and divided by whatever number on the top here. Okay, so you will get 2x squared. Okay, so I hope this will refresh your memory. So next one is we want to do b, which is gx equal to cos x. We want to find g capital letter x, so integrate cos x dx. We will get, integrate cos, you will get sin x. Okay, and the final one, c, which is hx 2x plus cos x. So h capital letter x, integrate these two. Okay, integrate to x, you will get 2x squared over 2. Integrate cos, we will get sin x. this can, okay, so this is the final answer. Okay, if f is an antiderivative of f on an interval I, then remember whenever you you integrate something, you have to do this plus c, which is the constant. Okay, so now let's look at this, the antiderivative formula, or also integral formula. Okay, so when you, okay, I really don't have to explain any further, because you have come across this integral formulas or antiderivative formula many times before. So now we want to solve example 2 together. So we'll start with A. What is A? A is fx x to the power of 5, and we want to find the antiderivative, which is f capital letter X, x to the power of 5 dx. Okay, remember? Okay, if you don't remember, let's look at the table once again. So x capital letter 5 kan tadi just now. So 1 over x n plus 1 is 5 plus 1 over, wait, I want to show you this. Okay, x 5 plus 1 over whatever function on the top here. Okay, so 5 plus 1 plus c, so it should be x to the power of 6 plus over 6 plus c. Okay, I know this is easy, I just want to refresh your memories. So gx is, the second question is 1 over third x, which can be represented like this. Okay, so you want to find g capital letter X, and x minus half plus 1 over minus half plus 1 plus c, and we will get over half plus c, which can be represented like this, 2 third x plus c. Okay, that answers a question, two questions. Okay, I'm going to erase some of this. Okay, so now we're moving on to question C. Hx is sine x. So h capital letter X is sine x dx. Okay, do you remember what is the integral for sine x? No worries, we can just look at the table here. Sine x, sine x, sine x is this one. So minus 1 over k cos kx plus c. Since we don't have, oh no, it's not sine x, it's sine 2x, my mistake. Okay, sine 2x. So sine 2x. So if sine 2x, okay, minus 1 over 2 cos 2x minus 1 over 2 cos 2x plus c. Okay, so that is C, right? C. And D, the question is Ix equal to cos x over 2. Let's check whether it's correct or not. Okay, Ix is cos x over 2. Okay, we want to integrate this. Okay, let's look back at the table. So cos x is cos kx. Integrate, we will get 1 over k sin kx plus c. Okay, what we have here is cos. This is also equal to cos half okay, which you will get 1 over what k here? K is half. So 1 over half sine half x plus c, which can be rewritten like this: 2 sine x over 2 plus c. Okay, so now we're going to solve question E. E is fx equal to 3x squared that satisfies f when we put, usually we see fx here, right? But now when we put 1 in place of x, it will give the result f1 equal to minus 1. This is also called boundary condition. Boundary condition is usually given in a question for you to find the value of c, the value of the constant. Okay, so now given is f small letter fx 3x squared. To find fx capital letter, you have to integrate it. Okay, so integrate this, you will get to the power of 3 plus c. So you have x cube plus c. So now you have the function so f to the power of 1 is okay. So you have this equation here. So it now is equal to 1 and replace 1 in the fx here. Okay, plus c, which we will get. So what is c? C is minus 2. Okay, so the final answer should look like this: fx equal to x cubed minus 2. Okay, guys? Okay, so now we're going to learn about area under a curve. To find an area under a curve, you have to do this equation. Okay, I know doesn't make sense right now. We have to do the example first. Okay, but first let me explain. Area under a curve is a non-conventional way to estimate the if you want to estimate area. Non-conventional way, and it's better to use integration. But the reason why I'm teaching you this is so that you know how very much more convenient integration is compared to this estimation. Okay, so now we want to do example 3 for question number 1. So let's look at the question again. Okay, the questions wants us to use rectangles to estimate the area under the parabola y(x square) from 0 to 1. So, keywords here is use rectangles to estimate area under the parabola. Parabola should look like this. Y equal to x square from 0 to 1. Okay, from 0 to 1, 0 to 1. We should use rectangles to estimate the area under here. Okay, now I'm going to make it more clearer to you in this next slides. So let's see the parabola. The graph of a parabola looks like this, right guys? Okay, I make it much more wider to make it much easier to you. So this is y equal to x square, and we want to find the area under 0 to 1. Okay, and the question wants us to use rectangles. So how I'm going to pick 4 rectangles to use. 1, 2, 3, and 4. Okay, so for rectangle 1, since it is divided into 4 rectangles, so the first one is 1 over 4, and second one is 2 over 4, 3 over 4, and the final one, 1, which is also equal to 4 over 4. So now the delta x is 1 over 4. Okay, let's look at the original question here. What we have to do is we have to find the delta x. So the delta x here is 1 over 4 for our particular question. And fx, what is fx? Fx is y equal to x square. So fx is x square. Okay, so now the area is 1 over 4, which is the delta x, times with x square. So x square here is 1 over 4 square, plus 1 over 4 times with 2 over 4 square, plus 1 over 4 times with 3 over 4 square, plus 1 over 4 times with 4 over 4, or I'm gonna write it down as 4 over 4 square to make it more clearer to you. So this can be rewritten like this: 1 over 16 plus plus 4 over 16 plus 9 over 16 plus 16 over 16. Okay, which you should get 1 over 4 times with 30 over 16. Okay, which can be simplified 15 and 8, and you should get 15 over 32. So this is the final answer for question for example 3.1. Okay, so now we want to do example 2. So example 2, let's look back at the question again. Okay, example 3.2 wants us to find okay, let's read the question first. Let A be the area of the region that lies under the graph of y cos x. Y cos x, how does it look like? Okay, y cos x look like this. Okay, between 0 and between x equal to 0 and x equal to pi over 2. Okay, by taking the samples point to be midpoints and using 4 subinterval. Using 4 subinterval is equal to what? Don't know yet. We have to do, okay, no, okay, of course we know. Okay, using 4 subintervals, so the delta x should be, since it is from 0 to pi over 2, so pi over 2 have to be multiplied with 4 subintervals, so 1 over 4. Since it is divided into 4 segments, so the delta x should be pi over 8. Okay, now let's do the question here. Okay, let me draw the graph so it will make more clearer to you, I hope lah. Okay, so this is from 0 to, we want to find the area from 0 to pi over 2. So it's a bit skewed, but never mind, I hope you will get the idea. So it should be from 0 to pi over 2, it should be divided into 4 segments. So 1, 2, 3, and this one is 4. So the first segment is, sorry, okay, let me write this again. Delta x is pi over 2 divided into 4 segments. So first segment is pi over 8. Second segment is what? 2 pi over 8. Third segment is 3 pi over 8, and the fourth segment, which 4 over 2 is also equal to 4 pi over 8. 4 pi over 8 equal to pi over 2 also, right? Okay, so now we want to find the a. So a is pi over 8. Pi over 8 is delta x times with what is the fx here? Okay, fx is cos x, right? Let's look at the, okay, fx, y equal to cos x, so cos x, so it should be times with cos pi over 8 plus pi over 8 times with cos 2 pi over 8. Sorry, not equal, plus pi over 8 times with cos 3 pi over 8 and cos 4 pi over 8. So this is the answer for question example 3.2. Okay, see you again, guys. Remember, you have to be diligent, be disciplined, even you have to study from home. If you have any question, you can ask me. Okay, okay, bye.